Hi, let's continue our previous video about the Cilium tunnel mode egress deep dive. So last time we talked about here encapsulating to node, that is encapsulating the packet, and so that's what here does. That's what this function does. It's kernel function to encapsulate the packet, then send a trace notify trace to overlay. So in the Cilium monitor log, it shows to overlay. Okay. So here, that's the to overlay. And the overlay interface is Cilium VXLAN, okay? And so then there's a contract lookup for the VXLAN packet. And you notice here, now the source IP is the node IP, and destination IP is the remote node IP, and the port is the VXLAN port 8472. Okay, and so here is the last monitor log for the data path for the egress, and that's the actual payload. Again, the destination port is the VXLAN port to the target node, and then the last trace log is to network. Okay, so and here this is the trace notify to network. Okay, so you might be wondering what happened after the encapsulation and redirect the packet, encapsulate the packet to the tunnel device, the Cilium VXLAN. Okay, so what happens after redirect to the Cilium VXLAN interface, redirect the VXLAN packet? The VXLAN packet will be processed by the host netfilter system, by the host stack in the host root namespace and host IP routing. So according to the target node IP address, and the host will do the IP routing lookup and to find the egress interface, which in this case is a physical interface for that Kubernetes node, and the physical interface has a BPF2 netdev program attached to it. In this case, the physical interface is this one. So in our diagram here, that's the physical interface, and it has a 2 netdev attached to it. So that's the last BPF program to process the packet. And but in this case, it actually just do a trace log to network and return the code. And after that, so the SKB lastly processed by the BPF program will be handled by the actual device driver to deliver the SKB packet. Yeah, so that's roughly what it does. So here again, why it happened here is we can get a confirmation from a diagram here. This is a diagram from Cilium benchmark test. So this is the left diagram is the standard container networking, and in the host namespace here, there is a IP tables processing for the packet, and also in the container, the pod namespace, there's also IP table processing. So that's a typical network processing for container and for the host namespace. But with eBPF host routing feature enabled, the host namespace IP table processing will be skipped, and so there is no more overhead for the netfilter IP table processing in the host namespace. Okay, so this mode, this optimization also works for the tunnel mode. So this is originally this is a diagram for Cilium direct routing, but it also works for tunnel mode. But there is confusion here. There is a confusion here because I noticed when I run the IP table trees in the host namespace with for the VXLAN packet 8472 to trace the packet for this destination port, I still see a IP table processing in the host namespace, and but here the diagram shows it should have no IP table net filter processing. So to clarify that, the author of BPF, Daniel Borkman, so he's the core maintainer of BPF in kernel. So he clarified on that, and he said the UDP stack for overlay, the VXLAN packet is still processed in the host namespace. The optimization is for this one, for the inner packet. So it will for the inner packet, that's the optimization here. No more net filter processing. So it's good to get that cleared, and so yeah, I think that's what I wanted to clarify here, and for the egress packet, right? So actually, I still have a little bit confusion about this part, the contract lookup, and for the UDP overlay packet. So I have not figured out what code trigger this, because in this this is my code path analysis, and after the encapsulation and the redirect to the Cilium VXLAN interface, there is another contract lookup, but what code actually does the contract lookup are still a little mystery to me. So if anyone can dive into it and make a comment, I would appreciate it. Yeah, so I think that's what I wanted to mention. And so there actually are more stuff to the egress, like in the kernel, how the in this schedule handle egress part, and then the actual NIC driver to transmit the packet for the egress part. So that's even more deeper dive. Maybe we can talk about in later video. Anyway, thank you for watching.